Understanding amperage ratings is crucial when installing devices like oxygen concentrators and nebulizers in a vehicle. The concentrator has a 4.3 amps rating, which indicates the actual current amperage drawn by the device when operating at 120 volts. The 3.3 amps calculated using the wattage is the average current, assuming a pure resistive load. In practice, the concentrator likely has additional components or an inefficient power supply, resulting in a higher actual current draw. The nebulizer has a 1.6 amps rating, which is the actual current drawn by the device. The relationship between amps, represented as I, and watts, represented as P, is given by the formula P equals V times I, where P is the power in watts, V is the voltage in volts, and I is the current in amps. Applying this formula to the concentrator, using the actual current of 4.3 amps, we can calculate the actual power consumption P equals 120 volts times 4.3 amps, which equals 516 watts. For the nebulizer, using the actual current of 1.6 amps, P equals 120 volts times 1.6 amps, which equals 192 watts. To determine the additional amperage output needed from the alternator, add the actual current draws of both devices. The total current equals 4.3 amps, the concentrator, plus 1.6 amps, the nebulizer, equals 5.9 amps. To support this additional load, your alternator will need to provide an additional 5.9 amps of output. This approach focuses on understanding the actual current draw rather than relying solely on wattage figures, which may not accurately reflect the device's power demands due to inefficiencies or additional components. Always prioritize safety when dealing with electrical systems and consult with a qualified technician if you are unsure about any aspect of the installation. The National Electrical Code, or NEC, provides standards for electrical installations to ensure safety. While specific NEC articles may not directly address mobile medical device installations, general principles of circuit sizing, overcurrent protection, and grounding still apply. Firstly, circuit sizing means ensuring that the wiring and overcurrent protection devices such as fuses or circuit breakers are appropriately sized for the load. Secondly, overcurrent protection helps to prevent overheating and fire hazards by interrupting the circuit if the current exceeds the rated capacity. Thirdly, grounding provides a path for fault current to flow, reducing the risk of electric shock. When selecting an alternator, it is essential to consider its maximum output capacity and ensure that it can handle the additional load imposed by the oxygen concentrator and nebulizer, plus any other electrical devices in the vehicle. It's also crucial to use properly sized wiring and connectors to prevent voltage drop and ensure reliable operation of the medical devices. Consider consulting with a qualified automotive electrician to assess your vehicle's electrical system and recommend an appropriate alternator upgrade if needed. Remember, safety is paramount when working with electrical systems in vehicles. If you are not comfortable performing the installation yourself, seek assistance from a professional to ensure that the work is done correctly and safely. Proper planning and execution will help ensure that your wife has reliable access to the medical equipment she needs while traveling. Additional factors to consider include the duty cycle of the oxygen concentrator and nebulizer. If the devices will be running continuously, the alternator will need to provide a sustained output of 5.9 amps. However, if the devices will only be used intermittently, the alternator may not need to provide as much continuous power. Also consider the efficiency of the power inverter if one is being used to convert the vehicle's 12 volts direct current to 120 volts alternating current for the devices. Inverters are not 100% efficient, and some power is lost in the conversion process. To account for this, you may need to increase the alternator output slightly to compensate for the inverter's inefficiency. Understanding the power requirements of the medical devices and the limitations of the vehicle's electrical system is crucial for ensuring a safe and reliable installation. If you have any doubts or concerns, it is always best to consult with a qualified electrician or automotive technician. To be more thorough, it would be best to measure the actual current draw of the oxygen concentrator and nebulizer with a multimeter. This will give you a more accurate estimate of the total amperage required from the alternator. A multimeter can measure the actual current being drawn by the devices under real-world conditions in the vehicle. Also, consider the effects of temperature on the performance of the oxygen concentrator and nebulizer. Extreme temperatures can affect the efficiency and power consumption of these devices. In hot weather, the devices may draw more current to compensate for the increased ambient temperature. In cold weather, the devices may draw less current initially, but the alternator may need to work harder to charge the battery. Monitoring the voltage of the vehicle's electrical system can help to identify any potential problems. A voltmeter can be used to measure the voltage at various points in the system, such as at the battery, the alternator, and the medical devices. If the voltage is consistently lower, it may indicate that the alternator is not providing enough power or that there is excessive voltage drop in the wiring. Consider also the importance of proper grounding. A good ground connection is essential for ensuring the safe and reliable operation of the electrical system. The ground connection should be made to a clean, corrosion-free metal surface on the vehicle's chassis. The ground wire should be properly sized to handle the expected current flow. Also remember the importance of using high-quality components. When installing electrical equipment in a vehicle, it is important to use high-quality components that are designed for automotive use. This includes wiring, connectors, fuses, circuit breakers, and other electrical accessories. Automotive-grade components are typically more durable and resistant to vibration, temperature extremes, and moisture than standard electrical components. The location of the oxygen concentrator and nebulizer in the vehicle can also affect the power requirements. If the devices are located far from the alternator or battery, there may be significant voltage drop in the wiring. To minimize voltage drop, it is important to use properly sized wiring and to keep the wiring runs as short as possible. It is also important to protect the wiring from damage by routing it away from sharp edges, hot surfaces, and moving parts. It is recommended to use a wiring harness or conduit to protect the wiring and to keep it organized. When installing the electrical equipment, follow the manufacturer's instructions carefully. The manufacturer's instructions will provide specific details on how to install the equipment safely and correctly. It is also important to follow all applicable codes and regulations. Finally, remember that the electrical system in a vehicle is a complex system. If you are not comfortable working with electrical equipment, it is best to seek assistance from a qualified electrician or automotive technician. Working with electricity can be dangerous, and it is important to take all necessary precautions to avoid injury. The NEC Section 310.13 addresses ampacity, the current in amps that a conductor can carry continuously under specific conditions of use without exceeding its temperature rating. NEC Table 310.16 provides ampacity ratings for various conductor sizes and insulation types, based on an ambient temperature of 30 degrees Celsius or 86 degrees Fahrenheit. Correction factors are applied when the ambient temperature differs. For mobile applications, temperature variations can be significant, so these corrections are important. NEC Article 430 covers motors, motor circuits, and motor controllers. Although an oxygen concentrator and nebulizer are not motors in the traditional sense, they contain motors that drive compressors or pumps. The NEC dictates that the overcurrent protection for motor circuit should be sized no larger than the values specified in NEC Table 430.52 or based on calculations in 430.52. This is to protect the motor and the circuit from overloads and short circuits. When calculating the total load on the alternator, include all electrical devices that will be operating simultaneously. This includes the oxygen concentrator, nebulizer, headlights, radio, air conditioning, and any other accessories. The alternator must be able to supply enough current to power all of these devices without exceeding its rated capacity. If the total load exceeds the alternator's capacity, the battery will discharge and the electrical system may not function properly. Also consider the reserve capacity of the battery. The battery provides a reserve of power that can be used to start the engine or to power electrical devices when the alternator is not producing enough current. The reserve capacity is typically measured in minutes and indicates how long the battery can supply a certain amount of current before the voltage drops to a critical level. When selecting a battery for a vehicle with medical devices, it is important to choose a battery with sufficient reserve capacity to power the devices for a reasonable amount of time in case of an alternator failure. A deep cycle battery is designed to be discharged and recharged repeatedly, making it a good choice for applications where the battery may be used to power electrical devices for extended periods of time. Standard automotive batteries are designed to provide a large amount of current for a short period of time to start the engine, but they are not designed to be deeply discharged. Consider using a battery management system. A battery management system, or BMS, is an electronic device that monitors and controls the charging and discharging of a battery. A BMS can help to protect the battery from damage due to overcharging, over-discharging, and excessive temperature. A BMS can also provide information about the battery's state of charge, voltage, and current. Another consideration would be to have a professional install an additional battery. Adding a second battery can significantly increase the amount of available power for the medical devices. The second battery can be connected in parallel with the main battery to increase the overall capacity, or it can be used as a separate power source for the medical devices. When installing a second battery, it is important to use a battery isolator to prevent the two batteries from discharging each other. A battery isolator is a device that allows the alternator to charge both batteries but prevent current from flowing from one battery to the other. Use a DC to DC converter. A DC to DC converter is an electronic device that converts direct current DC voltage from one level to another. A DC to DC converter can be used to step up or step down the voltage to match the requirements of the medical devices. For example, if the medical devices require 24 volts DC and the vehicle's electrical system is 12 volts DC, a DC to DC converter can be used to step up the voltage. DC to DC converters are typically more efficient than power inverters, which convert direct current to alternating current. One should make sure there are regular inspections and maintenance. Regularly inspect the electrical system for any signs of damage or wear. This includes checking the wiring, connectors, fuses, circuit breakers, and batteries. Replace any damaged or worn components promptly. Also, keep the battery terminals clean and corrosion-free. Corrosion on the battery terminals can reduce the flow of current and can cause the battery to discharge prematurely. Before starting any work on the electrical system, disconnect the negative battery cable to prevent accidental shorts. Always use properly insulated tools when working with electrical equipment. Also, never work on the electrical system when the engine is running. One should also avoid wearing jewelry or other metallic objects when working with electrical equipment, as these can conduct electricity and cause a shock. If you are not sure how to perform a task safely, consult with a qualified electrician or automotive technician. Proper planning and execution will help ensure that the medical devices operate reliably and safely in the vehicle. This includes proper wiring, circuit protection, grounding, and component selection. Regular inspections and maintenance will help to prevent problems and to ensure that the electrical system is functioning properly. When selecting an alternator, consider the cold cranking amps, or CCA rating. CCA is a measure of the alternator's ability to start the engine in cold weather. An alternator with a higher CCA rating will be able to start the engine more easily in cold weather conditions. Review National Electrical Code Section 517.13, which focuses on grounding for healthcare facilities, which has relevance when considering sensitive medical equipment even in a mobile environment. This section emphasizes the importance of minimizing voltage differences between conductive surfaces to prevent electrical shock hazards. Ensure all metallic enclosures of electrical equipment and non-current carrying conductive parts are properly bonded to ground. Also, NEC section 690.8 specifically deals with calculating the current of photovoltaic systems, but the principles of determining the maximum current a system can produce are universally applicable. This involves considering all sources of current and applying appropriate factors to account for various operating conditions and potential increases in current due to environmental factors or system performance.